Every once in a while, a piece of tech comes along that was designed for one thing, but it ends up changing pretty much everything. Today, we're talking about the ultimate example of that, an engine of a totally unintended and frankly, world-changing revolution.
So just think about this for a second. What on earth connects the wild west of cryptocurrency, the absolute cutting edge of biology, and the car you're probably going to be riding in a few years from now? I mean, these things feel like they're in completely different universes, right? But believe it or not, they're all being supercharged by the exact same piece of hardware. And yeah, the answer is the GPU, the graphics processing unit. That's it. The very same chip that was built to make your video games look amazing, to render all the explosions and shiny textures, has accidentally become one of the most important inventions of our time. Okay, so to really get how this happened, we have to look at what makes a GPU so different from a normal computer chip, a CPU. And it all boils down to one powerful idea: parallel processing. Here's a great way to think about it. A CPU, which is your computer's main brain, is kind of like a brilliant specialist chef. It's fantastic at doing one really complex thing after another, in perfect order. But a GPU is like an entire army of line cooks. It can't whip up a fancy 5-course meal, but it can chop 10,000 carrots at the exact same time. And that ability, doing thousands of simple repetitive jobs all at once, that's its superpower. And that power was about to be used for a lot more than just making games look pretty. And the first people to really figure this out and exploit it, outside of gamers, wasn't some big research lab. Nope, it was crypto miners. And this was the first real sign that the GPU was about to have a huge and incredibly chaotic effect on the real world. See, it turns out that the math behind mining crypto, solving all these complex puzzles over and over again, was the perfect job for a GPU. So starting way back in 2010, miners realized they could use these gaming cards, and they started buying them up like crazy. By 2017, it was a full-on frenzy. Prices went through the roof, and you couldn't find a graphics card anywhere. But the boom didn't last. China banned crypto mining, and then in 2022, Ethereum, a huge player, had a massive update that basically made GPU mining worthless overnight. All of a sudden, the world was flooded with all of this used but incredibly powerful hardware. And the scale of this whole thing was just mind-boggling. Get this, in 2021 alone, crypto miners spent about $15 billion on GPUs. I mean, that's more than the entire economy of a country like Jamaica. An entire global industry just popped up out of nowhere, completely dependent on a piece of hardware that was supposed to be for playing video games. So this crypto gold rush, it was a real wake-up call. It was the first time we saw that the GPU's unique power was so valuable, it could literally create industries, break global supply chains, and completely warp the market, all far outside of its original job description. But just as that crypto wave was pulling back, an even bigger one was forming: the AI revolution. And what do you know? It just so happened that the math at the heart of modern AI, training these huge neural networks, was another perfect job for the GPU's army of little processors. And this just shows you how dramatic the change has been. We've had to completely redesign data centers from the ground up. The old ones were built for CPUs, but the new AI factories, they're just packed with GPUs. And look at the power difference. We're talking a 10-fold increase in power density. That creates so much heat that you can't just blow air on them anymore. You need serious liquid cooling to stop them from melting. Now, to see why this is such a big deal, let's look at a real-world example: AlphaFold 2. This is an absolutely revolutionary AI that solved a 50-year-old problem in biology, predicting how proteins fold themselves into complex 3D shapes. This is huge for things like designing new medicines. But there is a catch. The original version was incredibly slow. So a team of researchers came up with this new system called APACE. And what they did basically was take that GPU philosophy, doing tons of things at once, and apply it to the entire process. They figured out how to get the data faster, run the first few steps at the same time, and then this is the key part. They split up the main AI job across hundreds of GPUs, all working together in parallel. And the result? I mean, it's just staggering. A calculation that used to take more than 8 days to run could now be done in just 64 minutes. That's not just a little bit faster. That's a complete transformation. It takes something from being a cool research project to being a practical, world-changing tool that can speed up science like never before. That's the power of the GPU. But, and you knew there was a but, all of this incredible power comes at a serious cost. all those GPUs and all those data centers running 24/7, they use a truly colossal amount of electricity. And this is the massive and honestly pretty alarming consequence of the AI revolution. This really puts it into perspective. A normal Google search uses a tiny, tiny bit of energy. But asking a question to an AI like ChatGPT, it uses nearly 10 times more electricity for a single question. And all those queries start to add up fast. Now, when you zoom out to the global picture, it gets even crazier. We're on track to more than double the amount of electricity data centers use by 2030. And the main reason for that explosion? It's AI. We're talking about adding the entire energy needs of a country like Germany just to power our data centers. And this isn't some far-off problem for the future. It's happening right now. Local power grids, especially in big tech hubs, are actually starting to buckle under the strain. This has become a serious bottleneck for our basic infrastructure. And that hunger for power is only going to get bigger. Because the next big push for the GPU isn't just in a data center somewhere. It's about putting that exact same power-hungry AI onto our roads and into our cars. The big idea, as NVIDIA's CEO puts it, is to let our cars think. To give them the ability to reason their way through all the weird, messy, unpredictable stuff that happens in the real world. The kind of stuff that has always been the biggest hurdle for self-driving tech. And the key here is a new kind of AI called Alpamayo. What's so special about it is that it doesn't just act. It creates what's called a reasoning trace. Basically, it can explain its own thinking. The car can tell you, in plain English, why it decided to slow down, or why it's changing lanes. And that kind of transparency is a massive leap forward for actually trusting these things on the road with us. And the stakes here are just enormous. Every single year, 1.3 million people die in car crashes around the world. The ultimate promise, the reason we're even taking this gamble, is the hope that this technology can bring that number way, way down. So when you really step back and look at it, the whole story of the GPU is just wild. It was born to make fake worlds look real, and it ended up fueling a financial mania, decoding our own bodies, putting a massive strain on our power grids, and now it's about to get behind the wheel. It has become this unbelievable engine of progress and change. But as its power keeps growing, so do the consequences. So the real question for all of us is, we've built this amazing engine, but can we actually afford the fuel?